All right, hello and welcome to lesson 8.3 for geometry, similar triangles. So your goal today will be to create similar figures using dilations and find missing measures in similar figures. Okay, so we're going to get started on this. So the first one we're going to do is a dilation. Now bear with me, this might take a little bit longer than you're expecting. So I'm going to pull out my ruler. Yours is going to be a little bit different, but your first task here when you're creating a dilation is to start from your center of dilation and draw straight segments through each point. Okay, so I have that. Okay, and I'm going to label these points just so I can see. We'll do A, B, C, and we'll call our center right here D. All right, and now your ruler measurements are going to be slightly different than mine because my ruler's not an exact ruler. I can make it bigger. So I'm going to say that's about 6.5. Oops, I don't want to measure from there, excuse me. All right, so my first step is to measure, again, we always measure from the center of our dilation. So I'm going from our center to point A, it's about 5 centimeters. So from D to A, it's 5 centimeters. All right, and then we're going to take that and get it close enough. And my scale factor up here is 1.25, so I'm going to multiply that by 1.25. And right, and I end up getting 6.25, so that means now I'm going to measure from my center out to approximately 6.25. That's my new point. All right, next I'm going to measure from D to B, and that looks like it's we'll say 4.75 centimeters. It looks like it's right there, so 4.1, 2, 3, 4, 5, 6, 7, 8. Let's call it 4.8. 4.8 centimeters, and that's going to equal, times it by our scale factor of 1.25, and I get 6. So now from D to my new point should be 6 centimeters, so about there. My last task then is to measure again from my center out to C. That looks like it's 5.5 centimeters. I'm going to multiply that by my scale factor again, and I end up with 6.875. So again, from C out to about 6.8 in between, about there. All right, so my new triangle now, if I draw it in, do it in yellow, is going to be from this new point over to this new point to this new point and all the way down to C. So you would take a straight edge, draw that in, and there's my dilated triangle. And again, if the scale factor is bigger than 1, that means your triangle is getting bigger, and I got a bigger triangle, so I've done it correctly. So I want you to pause the video, and in your notes, go ahead and try this one. All right, so your first step should have been to draw lines and then to measure from your center over here to each of those blue dots. And if you've done that correctly, you multiply by a scale factor of 2, and yours should look something like this. That point is a little off. All right, yours should look something like this. It's a little bit probably better, but I didn't go through the measurements. You should have. So again, it's getting bigger because the scale factor is bigger than 1. So if you have questions on dilations, please see me. All right, the next thing we need to look at is, well, in the previous 2 problems, they've given us the dilation factor, or also called the scale factor, and now we want to figure out how do we get the scale factor if we have 2 images. So if I'm looking at this, move this to the bottom. All right, as I'm looking at this, I see 2 triangles here. I'll show you them. So I see this first little one right here, and I see the next one going right here. So it says triangle ABC is similar to triangle EBD. So ABC is this little one that we have right here. Let's see if pink will go over. That little one and that big green one is EBD. So the dilation factor here, if I wanted to have a dilation factor that gave me the smaller one, I would do the smaller triangle on top. And be careful, it's not 3 to 6, it's actually to the whole side of that big triangle, which is going to equal 9. That would produce the small triangle. If I wanted to produce the large triangle with my scale factor, meaning if I measured all the sides like it did in the previous one and multiplied by it to get the large one, I would do 9 over 3. And both of these simplify to 1/3 or 3 over 1. So all this one asked you to do was to give you the dilation factor. So pause the video and see if you can find the dilation factor on this one. All right, I hope you found it one of two ways. Again, here's our small triangle, and our big one is right here. So this little guy right here is 4 centimeters. So again, if I wanted to get the small triangle, I'd do 4 to the whole side, which is 6. I could also look at these two. Those are the bases of the triangles. I don't need to do any adding on this one. I just need to compare 4 to 6. And again, I get the same ratio. And if I wanted to simplify that, that simplifies to 2/3. If you wanted to produce the big triangle, all you'd have to do is simplify it to 3/2. Okay. So now we're going to use what we know about similar triangles to find missing measures. So the first thing you got to remember is we need to know one ratio that we have both sides of. So this goes back to the same picture, big small triangle, and my big triangle here. Okay, so my small triangle, if I notice over here, I have the side of the small triangle, which is 2.5, and the whole side of that big triangle is going to be 2.5 plus 6.2, which equals 8.7. So my ratio that I know is 2.5 to 8.7. And let's say I wanted to find x first. I would have to do the small side of the triangle again, which is 3.4. All right, sorry for the interruption. We just left off with 3.4 here. And if we did the small side of it, we have to do the whole side of that big triangle. So we do 3.4 plus x. So that's going to be over 3.4 plus x. So again, I'm going to cross multiply. And when I cross multiply, I'm going to get 2.5 parentheses, don't forget your parentheses, plus x equals 3.4 times 8.7 is 29.58. I'm going to distribute 2.5 times 3.4, 8.5 plus 2.5x equals 29.58. Then I minus my 8.5, subtract it from both sides. 2.5x equals 21.08. Okay. And lastly, divide by 2.5, which I've been calculating. Which gives me 8.432 for x. And I'm going to use that same ratio to find y. So see if you can set up a ratio to find y. So if I use that 2.5 over here, over my total side, which is 8.7, the base of the small triangle is 4.6. The base of the big triangle is y. This one's a little bit easier to solve because I don't get those parentheses. 2.5y equals 7 times 4.6. 40.02. I'm going to divide by 2.5. And I get 16.008. So I hope that you can see how I've set those up. Okay, so and last thing we need to do with similar triangles is look at the similarity conjectures from chapter 5. So if you recall from chapter 5, side, side, side was a similarity conjecture. Side, angle, side, and the flip of that, angle, side, angle. And the last one was side, angle, angle. Those were the 4 congruent conjectures from chapter 5. Now we're going to take a look at similarity conjectures. So for example, if I know this is 4, this is 2, this is 8, this is 4, And this is 6, this is 3. If you notice from the small to the big one, all they're doing is multiplying by a half. If we know that all three sides are proportional, we know they're similar, so we know one conjecture is going to be side, side, side. Right, if I took away one of those sides, and I gave you that, let's say these angles are both right angles, so they're congruent, would we still know that they're similar? And the answer is yes, because if we have two fixed side lengths here and a fixed angle, this last side has to fall exactly into place, and so those would be proportional as well. So our second similarity conjecture, now not congruence, is side angle side. And the last one is, we know that the angles in similar figures have to be congruent. So if I left that angle in there, and let's say I told you that angle, if this was 30 and that was 90, we could subtract from 180 to get 60 here. And we could do the same thing over here because we know the angles have to be congruent. So I'd get 60 degrees. So in actuality, I don't need to give you the fact that those angles are congruent because I can always subtract from 180 to get that third one. So our last conjecture is not three of them. It's just we need two angles to determine that they are similar. So restated nicely, side, 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 angle, angle, and side, angle, side are my three similarity conjectures. And the difference between similarity and congruence is S no longer means that the sides are equal or congruent. It's that they are, the key word is proportional. In similar triangles, the angles are still congruent. Okay. So quickly take a look at this. This conjecture would be all three sides are proportional, and you would check that. 5 divided 2.5 better equal 13 over 6.5, which better equal 12 over 6, and all of that simplifies to a scale factor of 2. So they are similar by side, side, side. Right, looking at this one, I have two angles, so I hope you're thinking angle, angle. And again, you can guess the first three start off pretty easy. This one is by side, angle, side, and you'd have to check 5 over 2.5 better be equal to 12 over 6. Again, same factor of 2, and the key is the angle has to be between the two sides, because that has to be side, angle, side. Looking at this one, see if you could determine if these are similar and by what conjecture. I hope you went back to chapter 2 and said, oh, I know these angles are vertical. They are vertical, and you need to check 12 over 9. Is that the same ratio as 8 over 6? And the answer is yes. They both simplify to 4/3. So by side, angle, side, they are similar. All right, let's look at these. Are these ones similar? Take a second, pause the video, and see if you can figure it out. And I hope you came to the conclusion that yes, by angle, angle, they are similar. And the key is we have the 105 being congruent. Notice we have a 50 here, and we're missing that angle over in this triangle. So I could do 105 plus 25. Get 135. I'm going to subtract that from 180. Okay. Oops, I added the incorrectly. That's 130. I added another 5. And I should get 50. And the answer is, since those two angles are congruent, angle, angle is our similarity conjecture. Right, looking at this one, those two lines are parallel. So take a look, figure out if it's by side, 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 angle, side, or angle, angle. The easiest ones are these vertical angles, and since these are parallel, I technically know those are alternate interior, and technically I know that these are also congruent by alternate interior. I didn't need all three angles, I just needed 2 of them, angle, angle. All right, this one gets a little tricky, so what I'm going to do, I want you to pause the video for maybe a minute and see if you can figure out if these are similar by checking to see if the sides are proportional. All right, so I've got this triangle, and I'm going to take that small one and rotate it so it looks just like it's in the same orientation of the big one. So ignore this one over here now. I've moved it. So if you look at this, 24 on the big one compares to 16 on the small one. So 24 over 16 has to equal 30 compares to 20. And our last one, 36 to 24. All of those simplify to, let's see, 24 and 16 are both divided by 8. So we get 3 halves. 3 halves for 30 over 20, that one's easy. And 36 are both divided by 12. I get 3 halves. So yes, they are proportional. So the answer is side, side, side. Okay. Looking at this one, even if these sides are proportional, would they be similar? Take a second to think about that. And the answer is no, they would not be similar even if they're proportional because I would have an angle, a side, and a side. And so that is not a similarity conjecture. So not enough info, we could say. Okay. We don't know for sure if they're similar, but we can't say they are. Right, looking at this one, we don't have corresponding parts on this one. I have this side and not this side. I have one pair of matching sides and no angles, so this one you don't have enough information either. We don't have a conjecture that says that because none of our sides and angles are corresponding. Okay, we're going to skip that last one. We're going to skip this one. Okay, and I'm going to jump to the end of the lesson. All right, that is all we have for today. I thought I had another problem, but I didn't. So your homework, instead of being 1 through 9, is 1 through 7. We'll finish up the last conjectures you need for numbers 8 and 9. Is it Tuesday? I'm not sure, so. All right, well, have a good night. I hope this helps.